Guys, so today we're going to look at the bottom part of this, which we have not done. We've done some similar problems when we were working with the triangles earlier in this chapter, but I wanted to go over just one of these from each part. Okay, so I'm gonna do this one. This is the most challenging one from this part here. It says use a calculator to solve for 0 to 360 is what our answers have to be in. So we're going to round to the nearest tenth of a degree. If I look at my calculator and they're giving me the cosecant ratio, I would have to push second cosecant to find this answer for this angle. But I don't have a cosecant button. So I am first going to have to change this into a sine ratio. To do that, I'm going to rewrite this as sine theta. Now, if this is the answer to sine theta, to write it as a sine ratio, I have to flip this over, just like we did in the other part when we were doing the inverse functions earlier. So I'm going to have to do 1 divided by negative 2.9163. Now I'm going to have to check my calculator's mode, make sure that I'm in degrees. Change your calculator into degrees. How do I find the angle? What did I say I would have to push? Do I just push sine or do I do inverse sine? Inverse sine. So I'm going to do second sine of 1 divided by negative 2.9163. Okay, I'm going to close those parentheses and push enter. I'm supposed to round the angle to the nearest tenth of a degree. So this would be negative 20.1. I'm not going to put that as an answer though. I'm going to put it over here. Negative 20.1 degrees. Can anyone think of why this is truly not one of my answers? What do these directions say my angle has to be in between? Is this in between 0 and 360? So this is an angle that starts here and goes down to here in this direction. It just in this direction, negative 20.1 degrees. Remember how we learned about coterminal angles earlier? That's the coterminal angle would have the same answer, but it would go in this direction. So how am I going to find that angle that is just another name for this that goes in this direction? Right, so I'm going to do 360 minus that. Or I can just take this and do what? Plus 360. And I get 339.9. So that is in my range. So that is going to be one of my answers. 339.9 degrees. Now, between 0 and 360, is there any other place where sine would have a negative answer besides this quadrant? What other quadrant? Quadrant 3. So there's also an angle over here that would work. Well, this angle here has to be the same as that angle there. What was this angle here? 20.1. The only reason it's negative is because of the direction it was going, right? So this is going to be 20.1 degrees here as well. Okay, so that's going to be 20.1 degrees. So I now need to find the angle that starts here and goes to right there. So do you know what that angle would be, or how to find it at least? Good. So how did you get that? Right, so 180, oops, can't see that, plus 20.1. And that's going to give us 200.1 degrees. So for tonight, I'm going to want you're actually going to have time tomorrow to work on some things too. So if you want to wait until tomorrow to do these, you can. But that's what you're going to be doing in this section. All right, let's go down to this section now. And let's do just this problem. Look at the directions now. Use a calculator to solve each problem over 0 to 2 pi. This wording's not the best. Round to the nearest tenth of a radian. All right, so now what am I going to do with my calculator? Go under my mode, switch it into radians. Now, before we even start on this, though, I want to go off to the side here, and I want to talk about the radian measures. Right here is 0 radians. How many radians is right here? Pi. What's another name for pi in a decimal form? 3.14, right? So this is 3.14 radians. What about right here? How would you figure out what that is in radians? Right, I'd have to do pi divided by 2. Let's do that. That is pi over 2, and pi divided by 2 is 1.57. So right here is 1.57 radians. What is this right here in radians? This was pi over 2. This is pi. This is 3 pi over 2. Right. So I'm going to do 3 pi over 2. And so that right there in radians is going to be 4.71 radians. Okay, and then what if we go all the way around the circle? How many radians is that? Right, 6.28. Okay, good. We got a good idea now of what these are in radians. Now, let's do some estimating here. Well, before we do estimating, though, what am I going to have to change this into? Cosine theta. And what do I have to do to my answer if I'm doing cosine theta? Flip it. So I'm going to have to do 1 divided by to change it into a cosine problem. All right. So we're now going to do second cosine of 1 divided by negative 3.8358. And I get this answer. Seems like a weird answer, but based on what we just talked about, which quadrant is that in? 1.83, is it going to be in the first, second, third, or fourth? Second quadrant. Would it make sense for it to be in the second quadrant? Yes. So we have one of our answers then. It's 1.8. Oh, it says to the nearest tenth. We usually go, yeah, we'll go to the 10th. Okay, fine. 1.8 radians. Now, that is this angle here. That's 1.8 radians, right? Which other quadrant is going to have a cosine and secant that's negative besides quadrant 2? Quadrant 3. Now, think about this. We want the angle that starts here and goes around to there. How could we figure out that angle? Go ahead. Okay, so you're saying do 3.14 plus 1.8. That gives me 4.94. Is that going to be in the right quadrant? Okay, so that didn't quite work. Any other ideas? Oh, okay. So you're saying if we went all the way around, it would have been 6.28. We know if this angle is 1.8, then this angle is 1.8, right? Don't they have to be the same? If this is 1.8, then this is 1.8. So, yeah, he's right. We're going to do 6.28 minus 1.8. And we get 4.48, which is 4.5 to the nearest 10th. Kind of a tough problem when you're using quadrants 2 and 3. You have to keep working at it until your answer makes sense. Does this answer of 4.5 make sense? Would that be in that third quadrant like we need? Yes. So we're good. All right. So we're going to stop there for that video, but we want to do something else too. So hold on just a minute.